Okay, number 8. In a multiple choice test, there are 20 questions. For each question, there is a choice of 4 answers, and only one of these is correct. The choice of 4 answers, and only one of these is correct. So, from that statement alone, we can write down the parameters of this distribution. So, n is equals to 20, and p is equals to a quarter, because if there are 4 questions and only one of them is correct, probability of getting a correct answer is a quarter. So we can say that x follows a binomial distribution with parameters 20 and a quarter. So if a student guesses each answer, find the probability that he gets none correct. So what we need to find here is probability that x is equals to 0. And to do that, you can use your calculator. So if you go onto your calculator, you can just plug in, you're looking for PDF, binomial PDF. So probability of success is 20, number of trials is 20, probability of success is 0.25, x value is 0, and then you'll have your answer, which is 0.00317. Just checking. Yep. All right. So this is A1. So A2, the probability that more than 10 are correct. So x is greater than 10, which is same as 1 minus probability x is less than or equal to 10. And to find that, you can just plug in your calculator. So, but these are cumulative probabilities. So you'll go second, look for cumulative probabilities. And actually, before I do that, 1 minus, all right, because you have 1 minus. And then you go for cumulative probabilities of the binomial distribution. Number of trials is 20. Probability of success 0.25. X value 10. And you will be able to get your answer, which is 0.00394. Okay, so 0.00394. Great. Part 3, I'll just show you how to do it. You'll plug in your calculator by yourself. Probability no more than 5 correct. That means 5 or less. No more than 5 correct, so 5 or less. And if you plug that in your calculator, you end up with 0.617. Remember, these are cumulative probabilities, so use CDF to work out 3. I'll move to B. Now, in B, they want us to find the mean, calculate the mean and standard deviation. Mean is equals to the expected value, and the formula is n multiplied by p. Our n value is 20, our p is a quarter, and a quarter of 20 is 5. So that's the mean. The standard deviation is the square root of the variance of x. So, and we know that the variance of x is n multiplied by p multiplied by 1 minus p. which will be 20 multiplied by a quarter multiplied by 3/4, which will be 1.936. Good. C. Suppose that 5 students guess the answers to the test. So suppose 5 students guess the answer to the test. In this case, n is equals to 5. So 5 students are the ones who are whatever guessing. What's the probability that at least 2 of them get more than 10 answers correct? So what is the probability that at least 2 of them? So what we need to do is we need to formulate here a statement that will help us to write this. But anyway, before I do that, the probability of success here is, because they are saying what's the probability that at least 2 of them get more than 10 answers. What's the probability of getting more than 10 answers correct? That will be, so we have already calculated that here. If you look at our number 2 here, we've calculated the probability of getting more than 10 answers correct. So what we'll do here is we'll just say that the probability of success is probability of getting more than 10 answers correct. And we have calculated it here, which is happens to be 0.00394. Anyway, what I'll do is I'll write a statement that will make this clearer to you. So here we have a new variable. So we'll say y is the random variable that represents get more than 10 answers correct. All right. So, and we are saying that, well, y actually follows a binomial distribution with parameters 5, and the probability of getting more than 10 answers correct is 0.00394. So if we want to find what is the probability that at least 2 of the 5 students get more than 10 answers correct, then we'll say probability y is greater than or equal to 2. That is the same as 1 minus probability y is less than or equal to 1. And you can plug this in the calculator the same way you plugged in the other answers. So if you go onto your calculator and just plug this in, so 1 minus, and you're looking for cumulative probabilities. Number of trials is 5. Probability of success is getting more than 10 answers correct, which is 0.00394. X value is 1. Okay. Now remember, these are cumulative probabilities, and so that you have 1 minus that. Anyway, my answer is 0.000154 to 3 significant figures. So 0.000154. Great. Next question, which is number 5. In a large city, 18% of the people are left-handed. Okay. So if I can just start highlighting a few things here, 18% of people are left-handed, which basically means that probability of success is 0.18 in a random sample of 10 people, right? So sample of 10 people, which again means that n will be equal to 10 from the information that we have. So find the probability that exactly 2 of them are left-handed. So we need to create space below here. So probability, this is for A. Now, before I do anything, I may just want to write some statement to help you understand what's going on here. So I'll say X is the random variable representing the number of people who are left-handed before I write the distribution. So X is the random variable representing the number of people who are left-handed. Correct. So, and we can say that X follows a binomial distribution with parameters 10 and 0.18. So once you have that, we can start answering the question. The first question, A. Find the probability that exactly 2 of them will be left-handed. So probability X is equals to 2. And you can plug that in your calculator. I'm sure by now you know how to do it. So that will be 0.298. Move on to B. Find the probability that at least one person in the sample is left-handed. So at least one person, that means one or more, which is same as 1 minus probability no person is, or 0, none of them is left-handed. So, and if you plug that in your calculator again, I'm sure you know how to do that. It will be 0.863. All right. That's 0.863. I'm going to move on to C. Now, find the most likely number of left-handed people in the city. Most likely value, that sounds like mod to me. So most likely value will be the mod. All right. So we need to find the mod of X, where X represents the left-handed people. So to find the mod, what we have to do is we use our distribution and the calculator to inspect and find among these values which one of them will give us the highest probability. So if I just go on my calculator, so start, edit, just gonna clear all these probabilities. I'll add up to 10. So 7, 8, 9, and 10. Correct. And list 2, I'll plug in the probabilities. So second, look for probabilities, PDF. Number of trials is 10. Probability of success 0.18. X value, leave it blank. And then we should be having our probabilities all plugged in. Good. So we are looking for the value of x that will give us the highest probability, which will be the mod. And by inspection, I think it's 1. So the mod of x is 1. All right. So, and then right here, we are told that if another sample of 25 people from the city is selected, so here it's another sample, so which means our distribution will change. So basically, what I'm going to do here, below here, is write y follows binomial distribution with parameters 25 and 0.18. But the probability of success has not changed. It's the same. It's only that n is the one that has changed. So they're asking us to find, now this is for D, they're asking us to find the expected number of left-handed people in the sample. So expected value and multiply by p, which is 25, multiply by 0.18. And if you work that out, we'll get 4.5 as our answer. I'm going to move on to E. E, they're asking us to find the variance of the number of left-handed people in this sample. So the variance it will be n multiplied by p multiplied by 1 minus p. So that is 25 multiplied by 0.18 multiplied by 0.82. If you multiply that out, you should get that. All right. I'll move on to F, but just want to highlight something here again. If a sample of size n is to be selected randomly, so we have a new sample, all right? The probability of success, remember, is the same. It's only that we have a new sample. So what I'm going to do is, below here, I'll have another statement and say Z follows binomial distribution with parameters n and 0.18. Good. So what are they asking us in F? Find the minimum value of n for which the probability that it contains at least 2 left-handed people will be greater than 95%. So the probability that Z is greater than or equals to is greater than 0.95. I'm just going to change this statement to say 1 minus probability Z is less than or equal to 1 will be greater than 0.95. I haven't changed it. It's only that the left part that, you know, if I change it that way, it will be easier for me to handle in terms of calculations. So this is the same as 1 minus, and I'm going to just put a bracket here, probability Z is equals to 0 plus probability Z is equals to 1. Okay, cumulative probabilities, remember, greater than 0.95. Just going to create more space. This is same as 1 minus probability Z is equals to 0. Minus probability Z is equals to 1 is greater than 0.95. All right. Now I'm just going to use the formulas here for binomial distribution and choose 0, 0.18, to the power of 0, 0.82 to the power of n minus n choose 1, 0.18 to the power of 1, 0.82 to the power of n minus 1 is greater than 0.95. And then what I'll end up with is 1 minus n choose 0 is 1. 0.1840 is 1. So what I'll end up with 0.82 to power of n minus n choose 1 will be n. And so basically here I'll have n multiplied by 0.18 multiplied by 0.82 to power n minus 1 is greater than 0.95. Great. All right, let's see if we can simplify a few things. I'll move the 1 to the other side, so I'll end up with 0.82 to power n minus n multiplied by 0.18 multiplied by 0.82 to power n minus 1 is greater than negative 0.05. If I divide each side by a negative, I'll end up with 0.82 to power n plus 0 n multiplied by 0.18 multiplied by 0.82 to power n minus 1. Now, because I divided each side by a negative, the inequality will change. So I'll end up with whatever is on the left is less than 0.05. Now, at this stage, we can use our graphing calculator. So use GDC. And I'll show you how you can use the table in your GDC to find what n is. So if you go on your calculator, I'll move it. Okay, just let's keep it to the left here. So I'll go to y is equals to, and what I'm going to do is to plug in this function, the one on the left. So 0.82 to the power of x plus x multiplied by 0.18 multiplied by 0.82 to the power of x minus 1. I think I have everything. Great. All right. So if you go to second table to inspect the graph, you are looking for a value of n that will be less than 0.05. Okay, so you're looking for value of n that will be less than 0.05. Let's go. Okay, let's less than 0.05, and I think it will be the first value of n that will be less than 0.05 is 25. So n is equals to 25. Okay. Hope it makes sense to everyone. All right. So n is equal to 25. All right. Next question. In the same city, so might just want to highlight a few things. So this is G. So in the same city, the percentage of left-handed women is 0. Well, it's 16%, and the percentage of left-handed men is 22%. Looks like we have two distributions here. we have two distributions. So just keep in your mind, this looks like two distributions. A random sample of 5 women and 5 men. Like I said, these are two distributions. All right. Is selected from the population of the city. What is the probability that the sample contains at least one left-handed woman and one left-handed man? So these are two questions. Now, the fact that we have at least this and that, that means we're going to have to multiply our probabilities from the calculations that we get from these two distributions. So what we need to do here is to identify these two distributions, their parameters, and express them in probability form. Anyway, the first, let's start with for men. So this is G. For men, I'll use the variable M for men. So M follows binomial distribution with parameter 5 and 0.22. W for women follows binomial distribution with parameters 5 and 0.16. So these guys are asking us to find the probability W is greater than or equal to 1. And I'll multiply probability M is greater than or equal to 1. So all you have to do is plug this in your calculator separately. Remember, you have two distributions, that and that. Those are the parameters. You're going to have to work out that separately, and then you multiply your answers. So this will be equal to, if you work out the first one, I'll show you. So let's work out the first one. We can actually work out all of them together, hopefully. So that will be, yeah, let's start with the first one. Hopefully the calculator can give us this. These are cumulative probabilities. So number of trials, 5 for men, 0.22. And by the way, before I plug in that, this is the same as, because you cannot just work this discrete random variables. So what I'll do is, this is same as 1 minus probability W is equals to 0 multiplied by 1 minus probability M is equals to 0. All right. So what you can do, hopefully we can plug the whole of this expression in our calculator. So what I'll do is I'll go back to the home screen and work out the first one. Maybe I can use brackets. So go ahead and plug in CDF. Not really CDF. Hopefully. Okay. Bracket 1 minus PDF 5 0.22 0 plug in. Okay. Multiplied by 1 minus, again, PDF. There we go. 0.16. Plug in. Close the bracket. All right, and you have your answer. So 0.414. All right. Last question. So, on a TV news channel, the evening news starts at the same time every day. The probability that Mr. Lee gets home from work in time to watch the news is 0.3. So the probability that he gets home. So actually, I'll include Mr. Lee as well. Is 0.3. That sounds like a probability of success for me here. Calculate the probability that in a particular week of 5 working days, looks good, 5 working days, he gets home to watch the news, 1 on exactly 4 days and 2 on at least 3 days. Okay, the first thing we need to do is we need to we can say let x be the random variable that represents the number of days that Mr. Lee gets home to watch news. Great. So once you have that, we can write our distribution. X follows a binomial distribution with parameters 5 and 0.3. Great. So once you have that, you can go ahead and work out the first one. Probability he watches news in exactly 4 days. Sure, by now you know how to plug this in your calculator. So I won't show you that. You can do it by yourself. And you should be able to come up with this answer, 0.567. And 2, probability that he watches news on at least 3 days. So that means 3 or more, which will be 1 minus less than or equal to 2. Remember, these are discrete random variables, and your answer will be 0.163. All right.